Hello again, and welcome to Chapter 3 of our video series introducing the Anritsu MX280005A Vector Signal Analysis Software. Today we're going to cover the view mode and see how we can have a look at the IQ data in time. To begin with, I thought we just, since we did capture last video, we just connect to a spectrum analyzer. I have one on my network here, and I'm just going to plug in this is my those of you in the US will probably recognize this, but 98 megahertz is the middle of the commercial FM radio band, and so 20 megahertz bandwidth gives me sort of the full FM spectrum, and I just was going to pick one of these signals. This one looks good, nice and strong, so 100.7. So 100.7, and then we'll go down to a bandwidth that's good there, and 4 seconds. So I just want to capture an FM signal so that when we look at it we can kind of see what that looks like. And I'm going to click this load after capture and then capture that. So it takes 4 seconds to capture and then half a second or so to transfer, and then it's automatically loaded it, so it's ready for me to look at. So here it is, and now this is what we want to talk about today is this screen. It's my way of looking at IQ data kind of in its raw time-based format. When we get to the playback, we'll look at it in frequency space, but here it is. So what have I got? I've got I versus Q plotted here in this little diagram. I have a CCDF, and a lot of you may recognize that. It stands for Complementary Cumulative Distribution Function. If you don't know what it is, then you probably aren't familiar with it, and maybe it doesn't matter, but it's a convenient way to kind of get an overview if you're used to that. I also so I have plotted here kind of in my main part of the window magnitude I and Q, and I can scroll through that in time and look at it. Like I say, this is an FM signal, and that's what it looks like. I have the ability to turn on different parts of this graph. So if I want to just look at magnitude, for instance, I can do that. If I just want to look at I for some reason, or I and Q, usually I like to have all three of those on when I'm looking at it. And I have some markers. If I put the mouse here, it'll give me a little pop-up that says I can click to jump to a marker location, and I use shift click to set it. So if I want to set a marker somewhere, I say this was a point of interest, shift click, and I've set marker 1. Marker 2 works the same, except it's a control click. So if I scroll over and maybe there was some point of interest here and I hit control, then I've got 2 markers, and it tells me the positions, 635 milliseconds and 2.5 seconds. And I can click on these and jump to them. So it's just a way to have a couple of points and be able to find them. And for, in this case, I captured an FM signal. And when you don't know that that's a common thing, but if you capture an FM signal, then we have the ability to play it. So I can just hit this play FM. So that's what happened to be on that FM station when we did the capture. I can play AM. In fact, I can do it. I don't know if you can hear that, but there's nothing to hear because it wasn't an AM signal. And then I can save that to an audio file, which would be WAV by default, but we can convert it to MP3. And the save just saves whichever the last one. So if we played FM and then we hit save, it takes the sound that was played and creates a file that I can share with people. So that is most of what's here. Now, I do want to show this points of interest, and FM signal is not very interesting for that. So I'm going to quickly load a different file that I used recently. So I got my recent IQ files rather than go to my browse. It's just easy because I know that it was in this list, so I'm going to load it. Now this file, the reason I chose it is it's kind of interesting in that it's got regions with where the modulation is quite different. So I can see there's a certain frequency of up and down here, and if I scroll forward, that changes to a much higher frequency, and then it changes back to a lower frequency. And so those might be things that I'm interested in. So I have this part of the program called points of interest, and this little icon here that is the kind of the binoculars. That's my search thing. And so it will, if I click that, I'll do that now, it goes through my 3.8 million samples looking for places where something interesting happens in this IQ data, and it finds 3. And if I click on one of those, it jumps to that so it has a time mark here, and it centers that in my screen. And I can see, sure enough, the modulation frequency is slower, and then it gets much faster. So it located sort of that transition area as a point of interest for me, and then it's found a place where it goes back from fast to slow, and then from slow to fast again. So then it shows me the reason that it marked those locations was because of a modulation shift. It can also find power shifts. So those are the two things you might find. If the amplitude was really low and then suddenly it went large, then it would have tagged that, and there would be places in here. So you can find places where the modulation changes or the amplitude changes. And then the question is, well, how much does the modulation need to shift, or the amplitude, in order to make it into this? And so we have this little slider here that controls the sensitivity. All the way left is low sensitivity, and there's about 5 stops, and all the way right is high sensitivity. High sensitivity may find something like right here where it looks like this is a little bit longer than it is here or something, right? It's going to look for really tight places where it noticed that there's a change. And low sensitivity is going to require, a bigger change that lasts longer. And so if I were to put this on high, well, we can do it. So it's on high, and I hit this button, and it takes a minute. And then I've got all kinds of points in here, most of which probably aren't very interesting, and I might not even be able to look at it and even know why did it pick that out, because it's high sensitivity. If we have a small set of data and we're looking, there are times when you're going to look for things like that, right? So it's possible, but many cases I would recommend kind of starting with the crudest view and do these things, and you'll see points like that. What else is here? That's about it. This is just our quick and easy way. No option required. These first 3 things are free to our users. If you have an Anritsu spectrum analyzer, then you get to play with our data this way and look at it, and that's the easiest way to just get that overview and see the data in time. So thank you.